Hey, welcome to Introduction to C Programming. Today we are going to write a program using arrays, also using the random function generator. So here we have the program. We're going to write a program that randomly generates 5,000 numbers between 1 and 6. This is going to signify the number of a die. We're going to output the frequency that each number is generated. So a couple little notes here. This srand of time passing in null is going to seed the random function. Then we use rand to return a random number between 0 and rand max. This is defined in standard lib.h. We're going to have to include standard lib.h in addition to standard io.h that we usually do. And this is going to go up to be at least 32,767. So if we want to get a number which is between 1 and 6, we're going to have to divide rand by 6, and then we're going to add 1 to it, get the remainder of it, and then add 1 to it. Okay, so if we take the random number which is between 0 and 32,767 and we mod it by 6, that's always going to give us a value which is between 0 and 5. What we want is we want a value which is between 1 and 6. So that's why we add the additional 1 to it. Okay, let's go ahead and write this program. Open up Visual Studio. And let's go ahead and create a new project. I'm going to name mine Arrays. Win32 console application. Application settings, make sure you have console application, empty project, click finish. We're going to add a new file. I'm going to name mine arrays.cpp. So after you get to that, add a new source file, a CPP file called arrays.cpp. Solution Explorer should come up over here. There it is. Call it arrays.cpp. It opens up my window for me here, and we are ready to go. We're going to need to include two different header files today. We need the standard io.h because we want to do input and output, and we need the standard lib.h because this is where the random function, the random number generator is. Okay, we also need one more, forgot to say, to seed it with the current time, we have to include time.h also. Okay, so inside of our main function now, we need to create a few variables. The first one, we are going to create an array. Now, if we want 5,000 numbers, we could create an array with 5,000 numbers in it, and then just go through and find out how many times each one of those numbers occurred. This is one approach to this problem. I want to do this a little bit better so that we don't use that much memory. Why don't we create an array that has 6 elements in it, and we're just going to have this be like a counter. It's going to tell us how many times each one of those numbers came up. So let's create a number, a variable, called die number, and it's going to be 6 elements inside of it, and I'm going to initialize all of them to be 0. Now, we saw that there were a few different ways that we can initialize the variables to be 0. This is one way we can do it. I could have also created a for loop. I'll write this and then comment it out. This is another way that I could have done it. Oops. So that's another way that I could have done it. With it only being 6 elements, if I really wanted to, I probably could have just said die number sub 0 equals 0, die number sub 2, or sub 1 equals 0, die number sub 2 equals 0, and dot, 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 and so on, all the way down to die number sub 5 equals 0. That would have worked also. You see that there's this little squiggly line right here, and that's because the variable I has not been declared. So I would just need to do the int I, and that would get rid of that little squiggly line underneath the I equals 0. So this is another way I could have done it. I'm going to comment it out here. Since we did it the top way, this is just redundant to do it that way also. Okay, so what I want to do now is I want to loop 5,000 times, and I want to use that random number generator to get a random value between 1 and 6. So what I'm going to do is, first of all, we call this srand function, and I pass in this time variable. What's happening, the srand stands for seed the random. So it's seeding the random number generator, and we need to somehow seed it so that each time we run our program, hopefully, fingers crossed, we're going to get different random numbers. If we don't seed it every time we run our program, we're probably going to get what's called the same, quote, random numbers. And of course, that's not actually random if it's the same every time we run it. When we seed it with the system time, though, this is going to give us, hopefully, different random numbers every time we run our program, which is what we want. That's what's going to be actually, quote, random. The reason that I keep saying random and putting it in quotation marks is that there is no algorithm which is actually random. Obviously, it's an algorithm because there's a sequence of steps that we're running through, and we're going to get, there's going to be some deterministic output for what the number is. What we do is seed it with the current system time so that each time we run our program, it appears as if the numbers are different to us. However, if you knew what the current system time was, obviously the numbers are not going to be random. It's just going to be an algorithm that these values are running through so that we end up getting some number on the other side. Okay, so now that we have seeded the random number generator, where we need to have a loop that iterates 5,000 times so that we can then put numbers into our array for how many times each number came up. Okay, so let's create a loop variable here. I'm going to call this one counter. After I've seeded the random number generator, I'm going to have my for loop, starting counter at 0, having counter go up to 5,000, and then incrementing counter each time through. What I want to do here is just generate the random number. So I'm going to create another variable which is called random number, and I'm going to set this equal to 1 plus rand mod 6. So similar to what we just talked about looking at the slide. A random number is 1 plus rand, the function rand mod 6. So remember that this function rand is going to give me a value back between 0 and 32,700 and something, 67. So it's going to give me some number back here. I'm going to mod it by 6, which is now this part is going to give me a number between 0 and 5. I add 1 to it, so now that makes my number between 1 and 6. Okay? Now, inside of my array, in some element, I just need to add 1 to it. The question is, what element do I want to add 1 to? Well, since my array is 0-based, this first element here, which is die number sub 0, might actually represent 1, and die number sub 1 is going to represent a 2, and so on. So this is die number sub 5, and that would represent a 6 coming up on my die. So here, I'm going to do random number minus 1, because my random number is now between 1 and 6, but my array is between 0 and 5. Okay, you can see that maybe a little optimization I could have done here was make this just random number and get rid of the 1 plus in front of that. I did this so it makes it a little bit more clear that we're dealing with numbers on a die which are between 1 and 6 though, instead of looking at it between 0 and 5. What this for loop has done for me now is this has added 1 each time one of the random numbers came up. And so now, if I just print out all of these random numbers, it's going to show me how many times each one of those numbers came up, where the sum of all of them should come out to 5,000, which is the number of iterations I had through my loop. So I'm just going to do a little formatting here in my printf. Here's the number on my die, and then the number of times that number occurred. Do a little more formatting where I have some underlines there. So nothing special there, just a little formatting so that the output looks nice. And now I'm going to loop again, because I need to print out all of the numbers in my array, but this time I'm just going to go from 0 up to 6. I'm going to use that same counter variable. I don't need to create another variable here because I'm never using counter anywhere else, so I don't need to use a different variable there. Now I'm going to print out the number that I have, followed by a tab, followed by the number of times that it came up, and a new line. The number that I want on my die is going to be my counter plus 1. I'll put parentheses around it just to clarify that I'm adding 1 to my counter variable, because that goes from 0 through 5, and counter plus 1 would then make it go from 1 through 6. And then the element of my array that I'm interested in is die number sub counter. And that's my program. Let's go ahead and build this, compile it, and then we will run it. We're not reading any user input, so we don't have any scanfs in here, so we're just going to run it and see what the values come out to. Okay, looks like we just have a little warning there using that time function. That should be okay here though. And there we go, build succeeded. Let's go ahead and run our program now. Okay, there's my program. So you see that each of those numbers came up close to about the same amount of time. They were all between, it looks like, 806 and 867. So rather close to each other, a range of 61 values. And if I run this program again now, let's go ahead and run it again. See what comes up there. And you can see here that the numbers did come out to be a little different. What that tells us is that my random number generator here, this rand function, actually worked for me. So that worked out pretty well. It's working so that I have different values each time. You can easily figure out percentages if you like also. Just do a division by 5,000 and that'll give you the percentage that each number came up. That would be pretty easy to do. Just right here I'll add a percentage column. And as a third parameter here, I'll put another \t and then a %f. And this is just going to be a die number subcounter divided by 5,000. And I'll do a 5,000.0 so that we actually will get a float value there instead of getting an int. This number here that we have is an int, so we probably want to typecast that to a float also. And then let's build it. Hopefully this is going to work and give me a nice percentage. It's going to be a long one. I should have done a %.2f or something there at the end. And you see that it's pretty close there. So 16.96, 16.62, 16.98, 16.56, 16.88, and 16.00. So they're all about 16%. That's pretty close to random, because a random number generator should hopefully give us something which is evenly dispersed among all of the numbers. Okay, so that's our program. One other thing that I want to add in here is let's go ahead and add one of our pound define statements. We've talked about this in the lecture. I'm going to define the number of rolls of my die to be 5,000. And now, where we had our 5,000 right here, I'm going to put num rolls. And hopefully we can maybe do it down here also. Num rolls, just like that. And let's see if this is going to compile up for me. Nope, it looks like it's not going to let me. Right here, error syntax, so it didn't like this little trick that I was trying to pull off right there, putting that .0 at the end of it. It didn't seem to like that. So what I can do here is just put the 5,000.0. It's not going to affect anything right here because counter is still going to be less than that even as a float. So let's see if this is going to compile, getting rid of the .0 from the end there. Yeah, it looks like that succeeded. Let's go ahead and run it. You see that that worked out for us here. Change the percentage a little bit. It should change each time that we run it, slightly. Let's see, I'm going to do something else here. First of all, I'm going to take this value that I have and I'm going to multiply it by 100 so that I can move the decimal place over, and then I'm going to make this a %.2f, make it print out a little bit nicer. And while I'm at it, let's see what happens if I change this from being 5,000 up to 10,000. See if things are going to change for me there. So you see there I went up to 10,000, so we have more numbers here, and there's my percentages. Running it again, see if it changes it. Looks like my tabbing is off a little bit just because the numbers are shorter than the words that I have there. See that it changes it a little bit, so that's good. If I wanted to fix that, I could just put a second tab right here, and that should line everything up for me. You can keep changing the number of rolls if you want, make it bigger, smaller. All that's changing here because of how we've written this is the number of times we're iterating through the loop and what number we're dividing it by down in this area here. So this actually makes it very efficient since we only have our array with 6 elements inside of it instead of having our array with the number of elements that we had and the number of rolls. So we're actually not going to consume any more memory. The only thing that's going to happen is that it's going to have to run a little bit longer each time we do it, but the amount of memory that we're consuming is still going to be exactly the same. So it makes this program somewhat efficient, and you can change that number and it should run. It might take a long time to run. So let's see if I go up a little bit bigger. Let's see, what number is this? This is 10 million. So rebuild my array, or sorry, my code, and run it. You see it takes just a split second before it pops up there. It still does it. My percentages are starting to get very, very close to each other as I get even bigger. So that was 10 million. There's 100 million. This would be 1 billion. So let's go ahead and compile that up and run that. So you see here's where it's running. So it's taking time because it's having to loop through right here, this for loop that we see here. It's having to loop through that 1 billion times. So let's see if this is going to pop up for me relatively quickly. I don't know exactly how many times it takes to run through a for loop with 1 billion numbers. Let's see, that's a million. Yep, that's 1 billion. So taking a little bit of time here. I can hear my CPU fan has come on right now. It's iterating through here. It's probably taking a lot of the CPU. Hopefully it's not affecting the quality of the video. There we go. It popped up for us here. Now you see these numbers are very, very large. These numbers over here, the percentages get very close to each other. And since the numbers got larger, my tabbing got messed up. So I could move my numbers back here now. Get rid of that extra tab if I was going to line it up on this. Okay, hopefully you enjoyed this program, kind of interesting one. You got a little experience with arrays, with the random number generator, and dealing with the define, the preprocessor directive. Okay, if you have any questions, let me know. Good luck.